This is what I was going to go over in the WIN session for multiplication counting principles, factorials, permutations, and combinations. Just going to be some quick examples that we'll go through, hopefully refresh your mind on what we were doing at the start of this chapter. So, first questions are, which technique would you use to solve the following problems? Remember, when we're talking about solving these problems, we're always going to be asking ourselves, does order matter? So this first one says a group of 25 students is going to elect a president and vice president. How many ways are there to elect these positions? If you notice here, there are two different positions that we are electing. And the order matters because they are important positions, president and vice president. And so if order matters, you should automatically be thinking permutation. Next one. A soccer team has 15 players and is selecting 2 team captains. How many different outcomes are there? So you notice in this one, we have 2 team captains that are being picked, kind of like we had president and vice president. However, these 2 team captains have the same job. Their job is not different, meaning the order doesn't matter in how we pick them. So if the order doesn't matter, and we're only picking 2 out of 15, you should be thinking combination. Next, it says a restaurant offers 3 appetizers, 6 main dishes, and 2 desserts. How many different 3-course meals can you eat? The easy giveaway that I wanted you guys to pay attention to is that if we have a word problem that has more than 2 numbers and the labels are all different, more than likely we are going to be looking at a multiplication counting principle problem. So MCP for that third one. Okay. Now, these ones are simply just plug into your calculator, or actually we're going to write out the computation. Okay? So we understand what factorials are. So when we're looking at this page, remember factorials, we're just going to multiply all the numbers together. So when you're talking 2 factorial, you're simply just going to have 2 times 1. That's the computation. 8 factorial would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Same thing for 4 factorial. Start at 4, go down to 1. So 4 times 3 times 2 times 1. And lastly, 7 factorial, same thing. 7, 6, 5, 4, 3, 2, 1. Alright, factorials are simply just multiplying all those numbers together. Thankfully, we have our calculator that we can plug the factorial into. These ones we're not solving, we're just writing the computation. Now let's go ahead and look at some word problems. Remember, word problems, we always want to figure out what type of problem we're dealing with first. So in Gotham City, license plates are made with 3 letters followed by 2 numbers, but they are not allowed to use the letters J, K, or R. How many license plates are available? So license plates problems. Anytime we're talking about license plates, we need to remember that we're using MCP. Okay? So in this case, we have 3 letters followed by 2 numbers. What that means for us is we have 3 blank spots followed by 2 more blank spots. And we need to figure out what numbers we're going to put on those lines to multiply together. So keep in mind, in the alphabet, we have 26 total letters. However, for our 3 letters in Gotham City, we can't use J, K, or R. So if we take 3 out of 26, just showing you, we have 26, we're taking 3 away, you're going to end up with 23 letters for each spot. So our 3 letters are now going to be 23 times 23 times 23. Then it's followed by 2 numbers. There's no restrictions on the numbers, so remember you got to count 0. So we have 10 options for those. So you plug that all into your calculator, and you should end up with 1,216,700. Next problem. In Hogsmeade, license plates are made with 2 letters followed by 3 numbers, but they are not allowed to use the letter V. How many license plates are available? So once again, we start with our blank lines here. We have 2 letters followed by 3 numbers. So when we have that, now we can fill them in. We start with 2 letters, but instead of using 26, notice we can't use the letter V. So if we can't use the letter B, we really only have 25 options. So we're going to say 25 times 25 times 25 for those first, sorry, it should only be 2. Okay? So we have 25 times 25, and then we have 3 numbers. Those numbers don't have restrictions, so it'll be 10 times 10 times 10. When you multiply all those together, you're going to end up with a total of 625,000 different license plates. Okay, and the last one of this type of problem is Jeeps in Jurassic Park have license plates with 5 letters followed by 2 numbers, but they are not allowed to use the letters T, R, E, or X, the number 2. So how many different license plates are available? So we go ahead and start with our lines. We have 5 letters, 1, 2, 3, 4, 5, followed by 2 numbers, 1, 2. Now from there, we fill it in. Our letters, though, we can't use 26 because they took 4 of them away. So if they take 4 from 26, because we can't use T, R, or X, we're really left with just 22. So now I take 22 and fill in those first 5 spots because we have 5 letters. And then lastly, we have 2 numbers, but this time they do limit the numbers we can use. We can't use the number 2. So that means instead of 10 numbers, we only have 9 to choose from. So when you plug this all into your calculator, you should end up getting a very large number of 417,444,192 total different license plates. Okay, so that's your license plates problems. Remember, for license plates problems, you will always be using MCP. All right, now, your school offers 2 English classes, 3 math classes, and 3 history classes. You want to take one of each class. How many different ways are there to organize your schedule? If we think back to our key terms, first thing that I want you to notice is we're taking one of each. Usually when they say one of each, it's going to be an MCP problem. The other thing you can notice is that we have different labels. We're talking 2 English classes, 3 math classes, and 3 history classes. Those are all different classes. If we have 3 of them, more than likely it's MCP. So to figure out how many ways we can organize our schedule, we take our 2 English classes times our 3 math classes times our 3 history classes. You're going to end up with a total of 18 different ways. 18 different ways to organize your schedule. Next, you are buying a new car. There are 2 body styles, 5 colors, and 3 different trims. How many options do you have? Really no keywords here, but what I want to point out is all of our numbers, and there's 3 of them, have different labels. We're talking about body styles, colors, and trims. So if they have 3 numbers with 3 different labels, we're looking at MCP again. So we're going to take those 2 body styles times those 5 colors times those 3 different trims, and you're going to end up with a total of 30 different options for your vehicle. All right, now we get into just lining things up. How many different ways can we organize this stuff? So in how many ways can 6 taxis line up at the airport? My hint for you is if they give you only one number, more than likely it's a factorial problem. We always have to have 2 numbers for the combinations and the permutations, and for MCP you're usually looking for more than 2. So if they give you one number, you should be thinking factorial, especially when they're talking about lining things up, because we're saying the order matters, but we only have that one number that we're dealing with. So in how many ways can 6 taxis line up? Well, just keep in mind, you have 6 for the first spot, 5 for the next spot, because we already used the first one, 4 for the next, 3 for the next, 2 for the next, and 1 for the last. All right, the easy way of writing this is by just simply saying 6 factorial. So 6 factorial, you should be able to plug that into your calculator and find that you have 720. Next problem is very similar. How many different ways can 5 people form a line? So we're just lining people up. You'd start with 5, then you'd have 4 people left, then you'd have 3. So really we're just looking at 5 factorial. You take 5 factorial, plug it into your calculator, you should end up with 120. And last one on this page, there are 7 contestants for The Voice. How many different ways can the singers be ordered to sing? Okay, so different order of singers, but we only have one number. You should be thinking factorial, because we'd have 7 for the first option, 6 for the next, 5 for the next. So 7 factorial. Plug that into your calculator, 5,040. Okay, just keep in mind factorial problems. The hint usually is there's only one number and we want the order to matter. Next, how many ways can teams finish first, second, third, fourth in a 10-team tournament? When they give us positions, remember keywords, they gave us positions here, first, second, third, and fourth. The order matters. If order matters, we're looking at permutation. So I know we're finding NPR on our calculator. Then you ask yourself, what's my big group? Well, your big group should be that total of 10 teams. And your small group will be the number of teams that you're talking about finishing in first through fourth, which obviously would just be 4. So you take 10 NPR 4, plug it into your calculator, you should get 5,040. Next, we have 6 students entered their name into a drawing to win 3 different prizes. How many different ways can the winners be selected? The key term here is the fact that these are different prizes. So if they're different prizes, the order matters. So if order matters, we're thinking permutation again, NPR. So our big group was our 6 students that were entering, and our small group is the 3 that have the possibility to win. So you do 6, NPR 3, and you end up with 120. And last one on this page, a teacher selects 2 students to do 2 different jobs each day. If there are 20 students in her class, how many different ways can a teacher assign these jobs? Key term here is that they're different jobs. The order matters here. Okay, they throw an extra 2 in there just to mess with you. But all we really care about is that we're starting with 20 students and we're going to pick 2. Like I said, they're different jobs, order matters, permutation. We have our big group of 20 total students and we know that we're choosing 2. Okay, so really that 2 comes from here. It's 2 students and 20 students. So 20 NPR 2, you should end up with 380 different ways. All right, last slide of examples, just 3 more to do here. A box contains 6 colored pencils. How many sets of 3 colored pencils can be chosen from? Keyword being chosen. If we're choosing, we don't care what order they come in. So if order doesn't matter, combination. You still ask yourself, what's the big group? We have 6 colored pencils. Small group, we're choosing 3. So 6 NCR 3 gets you a grand total of 20 different ways. Next one, how many different ways can you create groups of 3 from a class of 20? Keyword being groups. So if we're talking groups, order doesn't matter, combination. And we have big group of 21, small group of 3. You plug that into your calculator, grand total of 1330. And lastly, you want to work out 4 days a week. How many ways can you choose the days you want to work out? Again, keyword being choose. So we use combination, NCR, and our big group is the days in the week. How many days in a week are there? Well, there's 7. So big group is 7. We're choosing 4. 7, choose 4, plug it in your calculator, you get 35. I know this was quick, but most of it is calculator work. If you need help with your calculator, please stop by my WIN session or ask during class.